All right, perfect. Okay, I hope we're all doing great, and I hope our day was fine. So, for day one, we had the front end introduction. Day two, we had the product design introduction. And here we are in the final day of the 3 days web development masterclass. And we're going to be focusing on the backend side of web development. Okay, so without taking much time, okay, maybe I should ask a question. Can someone just tell me maybe something they got to learn yesterday from the previous class? So maybe I'll go with Grace for today. Hi, Grace. Can you just get to tell us what you learned from the class yesterday? Either yesterday or the first day, anyone?
Good evening. This is also my first class actually.
Okay, this is your first class?
Yes.
Okay. All right. Okay. How about you? I asked Salam the last time. NEPLAB. I don't know if I'm pronouncing it correctly. NELAB. Hi, NELAB.
Hi.
And what country are you joining from? Are you Kenyan? What?
Nigeria.
Nigerian. Okay. Your name, or is that a nickname?
That's my name.
Okay. What tribe is that?
I'm from Plateau State.
Oh, wow. Okay. Oh, that's an interesting name. All right. Okay. So can you tell me about what you learned previously from the last class or the first class? Anyone you want to touch base on?
Yesterday I learned product design is about solving real problems,
Mm-hmm.
and it should be beautiful, usable, useful, and enjoyable. And I also learned like the design process, problem research, ideas, design, and tests.
All right. Okay, that's great. Thank you so much. Okay, so without taking much time, so we're just going to move straight to the class today, and I'll be introducing our speaker, which we have Emmanuel Adebi joining us this evening. So Emmanuel, he's a software engineer with lots of experience building user-friendly and performance apps and services. He is passionate about research, training, and knowledge sharing. In his spare time, he loves to read books, watch sports, and start side projects that he may or may not complete. Interesting. He holds a bachelor's degree in computer engineering and he leads the Gen AI infrastructure development efforts at Text Gorilla. All right, so that's really impressive. At DB, and it's nice to meet you. You joining us here this evening. So, all right, you have the floor. So Adebi is just going to be running us through the whole overview of the backend web development. All right, Adebi, let's go ahead. Thank you.
Thanks for the introduction, Victoria, and hi everyone. Nice to meet you all. Please confirm if you can hear me well. Awesome. All right. Like Victoria said, Emmanuel, and I build backend systems. I write code and build systems. And today we want to just dive a little bit into the world of backend systems and how they work. I've prepared some slides just to guide us through the journey. And after we run through the slides, I'm going to open us up for questions. We take a few questions and then we do a bit of hands-on practical. So I've prepared a a roadmap for us. I've shared that already with Victoria, and she'll be sharing that with everyone after the session. But what the roadmap gives you is an hands-on project with examples that you can actually use to build backend systems in Python. So it takes you step by step through the fundamentals, network, to more complex building blocks like models, validation, persistence. We'll talk about a few of those things. But what we'll do right here on this call, hopefully in about 30 minutes, is we're going to try to build a real-time Telegram bot right here, from scratch, all of us together, a bot that can respond to messages that you send from Telegram. So I hope you all find this exciting and interesting, and really passionate about sharing knowledge. And I hope you get to learn something or the other. Without any further ado, let's dive into it. Sharing my presentation. Please confirm if you can see the presentation. Is it visible? Oh, let's try it again. Looks like we didn't see that. All right, how about now? Can we see the presentation now? Perfect. All right. So we want to talk about backend engineering, just like I said. And backend is really all about connecting systems, right? We're all very familiar with user interfaces, apps, and the things we interact with on a day-to-day basis. When you open your WhatsApp, type into your email, or do anything on the internet, Twitter, Instagram, you're dealing with a user interface. And that sometimes obscures the fact that there is a lot of operations happening behind the scenes to power that experience that you can see visually at the front, right? And that's really what backend systems are all about. So you can, have the nicest user experience if there is no backend behind it, if there is no strong system, reliable APIs behind that system, then it's just the mock, it's just the UI. It doesn't do anything. And that's why backend systems are very, very important. Every application you see somehow, somewhat has a backend behind it. And when you want to think of backend, just think of it as the engine behind whatever application you're dealing with, be it Instagram, Twitter, whatever social media networks, whatever apps you're dealing with typically has a backend, an engine behind it that powers it. It's just a perfect illustration for what a backend is. You have a car, and your car has, the chairs, the steering wheel, the body, the paint, the glass, and all the fancy stuff that people see and interact with, the gears and all. However, hidden inside of the car is the engine, and that's what really gets the car moving. Right? It's not the paint, it's not the seat belt, it's not the chair. All of them contribute, and they're very important parts of the user experience. But what really gets the car from point A to point B is the engine, and that's really what a backend system is. Now, what is this backend all about? How does it work? So the backend is built on the core principle of the web, which is the hypertext transfer protocol, HTTP. And sure we're all very familiar with HTTP to some extent, even if the only place you've heard about it is when you're typing a URL and your browser changes it to HTTPS, something like that. Everyone knows the HTTPS, and that is basically the language the web speaks. In order for your UI, your web app, your mobile app to communicate with some system somewhere, for you to post your, pictures on Instagram and update your status on WhatsApp, your picture or your email or that data is captured and sent somewhere through a particular language. And that language is what we call the hypertext transfer protocol. And there's a number of pieces in how it works. The model it's built on is called the client server model. So you can keep that in mind. It's a very useful thing to know. The HTTP works on a client server model. And that's not complicated. That means a client simply requests for something and the server responds with an answer. So it's basically at the restaurant, you are a client and the waiter is the server. When you say, I want a drink, they bring the bottle of drink. When you say, I want food, they bring food. That's literally how it works. It's as simple as that analogy. All of the web in its current form basically works, roughly in a client-server approach. And HTTP has a number of verbs. That means there are different kinds of requests that you can make. So you can see from my slide on the client side, you have get, post. Get basically means I want you to give me something. So if you're thinking of your backend systems today, a get request is basically when you type into the Google search food that starts with A, you want Google to get for you all the foods that it can find that starts with A. And you can assume that somewhere in that process, a get request is being made to Google server to fetch from the indexes of foods that they have or lists that they have the food that starts with A. That's literally how that works. And then we have post. These two are basically the most popular verbs. There's about 10 of them. You can read up on the HTTP RFC later, and my bootcamp project on GitHub, which I've prepared and will be shared with you later, contains more on that as well. And the post basically is saying, I want to send something to you. And that's basically you saying, upload this picture to Instagram. That's potentially a post request because you're sending something to the server. It's basically you going to a restaurant. Let's continue with the restaurant analogy, and giving your waiter a chili pepper and say, this is the pepper I like with my food. Take this pepper and use it to prepare my food. And that's a post, right? When you say, give me the menu, that's a get. You're requesting for the menu, requesting for the things that they have. But when you say, take this and use it to prepare the food for me, that's a post. And that's really how it works in a client-server approach. Now, the second thing you can see here as a core component of backend systems is the DNS. And what's a DNS? A DNS is basically a domain name server. And I'm sure at some point we've heard about, I want to buy a domain. Say the name is Emmanuel, like me, for example, and you want to build a website. You probably want to go to a domain provider like Cloudflare, GoDaddy, or whatever, and say, I want to buy emmanuel.ng so that my website can be on emmanuel.ng. Now, anytime you type emmanuel.ng into the web, into your browser, how does the internet know where to fetch the data in emmanuel.ng from? Anytime you type youtube.com, it's just a string of text, right? How does the internet know what data to return to you? And you probably type some other thing and it say nothing found, right? How can the internet distinguish between what's available and what's not available? And that's really where DNS comes in. So to dumb things down and make things really, really simple, every server, let's not forget, I just talked about the client server protocol, which is what HTTP is based on. The client is basically, in this context, your mobile phone or your computer or anything you're browsing the internet, the web with, while the server is whatever is serving those pictures, those videos, those images, those website content back to you. That is the server in the context of the internet. Now, every computer on the internet, both the client and the server, that's your phone, your laptop, whatever, has an IP address, which is the internet protocol address. That IP address is basically a unique identifier that the internet can use to identify any particular server or client on the internet. And what DNS does is when you type youtube.com on the web browser, the browser basically reaches out to a DNS server and says, I'm looking for an IP address that matches the text youtube.com. And if it doesn't find anything, that's where you see that weird error on your browser. It says nothing exists or DNS error or whatever. But when something is found, that's when you get information back. So basically what's going on behind the scenes is the DNS translates the URL www.google.com into some numbers that is a unique address tied to a server. So every time you hit google.com, there is a server, a particular server that's responding with the response for google.com, right? And the IP address of that server is what youtube.com or google.com is converted to. It's as simple as that. The third component, which I've already obviously talked about, is the web server. That is what receives the request, processes it, and returns some information. That's why when you say google.com, you get something. When you say google.com/search/ who is Donald Trump, you get something else, because the request can understand the URL has some extra information, and I can respond differently than how I would respond if it was just google.com. That is basically what a web server does. And what we are going to do in this call, like I said, is we're going to build a very tiny web server that connects to Telegram and tries to, listen to some commands and does certain things. We'll just try to go as far as we can, as far as we can go before 10 o'clock WAT. All right. The next part here is the app logic, which I've already alluded to. The web server controls the app logic. Depending on what you type into, if you post a picture to your status, for example, and you exclude certain people from seeing it, that's some extra logic that's been baked into that request, right? If you are posting on Instagram, and I'm using social media analogies a lot because I know that's something we're all familiar with. If you're making an Instagram post and you add some music to it, that's an extra modification, right? Because if it's just a picture, then there is no need for audio. But then when you add the audio, some modifications are made to the logic to include an audio stream in the output. And that's, how when people see your post, they hear some music or whatever you've attached to it. And that's literally how that works. Now, the fifth component is the database. The database is basically where things are stored. When you create an account on Facebook, the next time you come back to Facebook, you're not creating an account afresh. All the data you've set within Facebook remains within Facebook, right? And that is the purpose of the database. Its purpose is to persist information about the user, about the application, about the services it's connected to, and whatnot. And the last but not least in this flow is the response. The response is basically the output that you get back. And you see that at the core of it, it's still just the computer garbage in, garbage out. If you know this and understand this completely, you are already in some way a backend engineer. Take it or leave it. I go to the next part here, just the layers, which I've talked about in great detail already. The web server, that's what receives the request. Typically within the web server, there is an application layer, and that's what's responsible for the processing of all the business logic, all the code logic, understanding the difference between the data request from user A and user B, and all of that. At the third level, we typically have a framework, and I'll go into that a bit more in the next slide. We have, tons of languages that you could use, and within languages, we have tons of frameworks, right? Some could use C#, which is my favorite language, or Python, or JavaScript, or Golang, Rust. There's so many languages, and the different languages have different strengths, right? And at the last level is the database, which is what is used for information persistence. Now let's take a look a bit at some of the languages, the popular languages that we have. We have JavaScript, Python, Java, PHP, Ruby, .NET. A few popular ones that I didn't add in the slide: Rust, Golang, C#. All these are very powerful languages that can be used to build very powerful backend systems. Majority of the internet today, a huge chunk on the internet runs on Node.js. A huge chunk of the internet runs on PHP, Java, and .NET. Modern systems more and more use Rust and use Golang, and you really can't go wrong picking any one of this. My recommendation is usually to explore as much as you can and find what you like. In terms of popularity, JavaScript remains the most popular language, and that would typically mean you have a lot of resources to work with in a large community to help with. And now with the age of AI-assisted development means that AI is uniquely capable to build things in JavaScript very quickly. Now the bootcamp I've prepared, I've used Python for it because beginners usually find Python very easy to work with. So I've selected Python for that, and would work with that for the context of today's class as well. All right. The next thing is, let's talk about data. I've told us about that the database is used for persistence and storing information. But how is this information stored? Is it stored in files, right? How does this database work, right? Is it basically a group of files like you have on your phone or on your computer when you visit the Explorer and you see it's grouped in folders and files? How does this retrieval work? So basically, we have two broad forms of database persistence in modern backend today. And there's the structural data and the relational data and the non-relational data. And don't let the big English scare you. Relational data simply means the data is arranged in tables, while non-relational means the data is arranged in flexible formats, like JSON. I'll show you perhaps what JSON looks like. JSON means JavaScript object notation. So if you're familiar with how JavaScript describes an object, that's basically what JSON is. And it's a very popular, if you're going to be a backend person, you're going to work with JSON a lot. And that's literally how databases are structured today. Now, there are trade-offs in using one or the other. For the non-structural, non-relational databases, we have like MongoDB, DynamoDB, Azure Cosmos. There's a good number of them. They're usually very highly scalable. Because they're flexible, it means they can be sharded and they can easily scale horizontally, right? On the other hand, the relational databases are organized into tables, and that means there's usually very strict rules. The advantage of that means very high performance. However, they typically hosted on single instances and are a bit harder to scale horizontally. Next, we'll talk about how different systems communicate. Systems typically communicate via APIs. I've already told us that, I've already mentioned to us that at the core of HTTP, we have basically a client making a request to a server and a server sending back some response. Now, you can think of an API, which API stands for Application Programming Interface. An API is basically a group of requests or or a group of let's not call it requests. Requests can be made to these APIs, but they're basically a group of functions that can be invoked on the server that are exposed to the client. Now, this API is basically the interface through which these functions that exist on the server can be exposed to the client. Just like your user interface is the interface through which you can click, you can touch on the screen, you can swipe, you can scroll, you can zoom. On the backend side, the API is the interface through which requests can be made from the client to the server. And there's a whole number of API architectures we have today. There's, long ago we had things like SOAP. Today, more commonly used is REST. And then we have GraphQL, we have gRPC. You don't have to be too bothered about all of this. You just note that REST is the most popularly used today, and backend systems that you would typically work in will be based on REST. And our example today will also be based on REST. Next up, let's talk about security. A very fundamental part of building backend systems is securing them. Think about this. What if everyone could access your emails, could access your Instagram accounts, could see who you were chatting with, could see, imagine a world where I could read your WhatsApp messages without you knowing about them, without you giving the consent for me to read them. And that's where security comes in. It is important that there is trust and privacy in information that's being carried from one part of the system to another. Because when you think about a backend, it's basically moving data, processing them, and returning some form of processed data between different systems. So how do we ensure that this data only gets to the right people? How do we ensure that this data only gets, to the people who need it, or the people who are authorized to see it? And that's where security comes in backend systems. There are security at different layers of the backend. We have at the network layer, at the application layer, and at the data access layer. I won't go too deep into how they work, but just give you an idea. We have HTTPS, which basically implements the SSL TLS protocol. And that's what ensures that when you are sending your requests over from the client to the server, there is some security in that transition. Because I won't go too deep, but the way the internet works, all the information you're sending, either myself, as you're joining this call right now, the streaming of videos from YouTube, all of that information passes through the same conduit, the same wires, the same internet service providers. All of that information goes through the same protocol, the same wires, the same routers. So how do we ensure that this data can only be decoded by the right people? That is why we use TLS at the network layer. So what TLS basically does is it encrypts the requests and the responses at the point when they're being initiated from the server, and when they've been from the client, and when they've been returned from the server. You might have been in a situation where you entered HTTP on the browser, and then it said, this website is not secure because they do not have an SSL certificate on it. And that's basically the network layer security that's available for you. On the application layer, which is basically the security available for you on the API, there's a number of approaches here. We have CORS, rate limiting. I won't go too deep into this, but I think you'd be getting the slides after now. So do your due diligence and look into them, understand how they work. And lastly, on the data and access layer, we have authentication, we have authorization, typically using things like cookies, JWTs, which is JSON Web Tokens, SHA encryptions, and a whole lot of protocols that we use to secure backend systems. Now, these backend systems, after we've built them, how do we put them on the internet? It's as simple as connecting whatever you have built. If you've built a tiny server, you just need to put it on an internet on a computer that's connected to the internet, where it can be accessed by any other person who has access to the internet. And today, this has been largely democratized by cloud providers. So in the old days, if you wanted to put something on the internet, you would typically need to get a very reliable internet connection, so that, and then expose your computer to the public internet. So basically, anybody who is trying to access things from your website is literally trying to connect to your computer. But now we have the cloud, the public cloud, which is democratized servers, and you, instead of hosting things on your local infrastructure, you can set things up on Azure, Google Cloud, AWS. There's a whole lot of them, Flywheel, Heroku, Fly.io. There's so many options in which you can host backend applications that you deploy. And that's typically how we deploy backend services today. The next thing I want to talk about is scale. And you might notice I'm not going to, because of time, into any of these individual topics, but I want to ensure that we have a large understanding on a general level of how these things work. Now, let's talk about scale. Think of Facebook. Facebook processes millions and billions of requests per second, because there is at least 1 billion people at any given time trying to log into their Instagram, trying to view posts, in the morning and the night, because of it's a global world, and these are global services that are available all around the world. Imagine all of that happening on a single computer. It's simply not possible, because there is no single computer in the whole world that can handle billions of people trying to connect to it at the same time. And that is why we needed to scale, come up with different kinds of architectures for scaling different things. Generally, there's much more nuance to this topic, but generally, there are two main approaches of scaling services. We have the monolithic approach and the microservice approach. The monolithic approach basically entails everything running in a single unit. And when you need to scale this up, you would typically scale it vertically by increasing the specification of the infrastructure. Say you have everything running on a single VM deployed on AWS, for example. You say you grew from 200 users to 1,000 users, and now the server is crashing because there are too many users. What you typically do is, I need to buy more RAM. So you buy more RAM to the computer. You buy more processing power, you buy more disk storage and things like that. On the other hand, the microservice architecture, what it does is it basically allows you to build your services in such a way that different parts of the service are scaled differently. And then it's much more easier for you to scale different parts of an application separately. For example, if you're on Twitter, the most crucial part of Twitter is the timeline. And most people are spending a lot of time on the timeline. Now, the other pieces like you're updating your profile picture, or chatting with Grok, or things like that. You don't spend a lot of time doing that. And you can imagine a world where if you had to scale everything, you had to scale it uniformly. So if you need to put in 20 gigs of RAM, for example, to the timeline, you'd also need to put 20 gigs of RAM to uploading profile pictures. And that's not practical, because uploading profile picture does not need 20 gigs of RAM. So a microservice architecture would basically split those functionalities into different services, and you would be able to scale, say, the timeline with 20 gigs of RAM and uploading profile picture with 1 gig of RAM. And that's on a very simplistic view. That's a very simplistic view of how these architectures work. Today, backend systems are the core of the businesses, the core of businesses, the core of services that run everything we're powering today. Think e-commerce, think AI, think whatever's happening on the internet basically happens on the back end. And that's why being a backend engineer is sometimes more than churning out code or building out infrastructure. You must be able to convert business logic into code, right? Because you're building a service that can scale to, say, 1,000 customers, and these thousands and millions of customers would have different needs. You would need to be able to understand the requirements of the needs of your business to cater for their customer base and translate that into the technical nitty-gritty that you would need to that your service would need to entail to succeed. So when you're thinking as a backend engineer, as you guys had the user interface class yesterday, I think, and when you're doing user interface, you have to think from the perspective of the customer. And when you're doing backend, you have to think from the perspective of the customer as well as from the perspective of the business. You need to put in validations that ensure the business is not at risk. For example, you have a wallet application. You want to be able to ensure that businesses or your customers cannot withdraw more money than they have on the wallet. You have to be able to ensure that one person cannot make withdrawals that would tamper with the ability of other customers to withdraw on the system. This kind of decision making are things that you would need to become conversant with. I'm sure you would, maybe using your bank application or something, you would try to do something and they would say, this is currently not available, try again in another 30 minutes or another 1 hour. These are security processes meant to sometimes secure you, sometimes meant to secure others from you. And these are the kind of things that you would typically need to think about when building backend systems. So it's a robust field. You need to be ready to wear multiple hats. If you're building a backend system for an accounting firm, you need to learn the basics of accounting. If you're building a backend system for a law firm, you need to get into the legal world and understand the nitty-gritty of law. So be open-minded, be ready to explore. It's an ever-learning journey. Now, finally, my last slide here basically talks about the key things that you need to succeed as a backend engineer. I've talked about HTTP. That is the fundamental thing the web is based on. Pick a language, right? Just start out somewhere. I, for example, started with C# back in 2014 because I stumbled on it and I absolutely loved it. Just pick something. It doesn't, you would hear a lot of things from people. This is the best, and everybody has opinions, and that's fine. But you just have to pick something and stick with it. I know people never got anywhere because they kept changing because of what they've heard from someone or the other person, and they never got to make significant progress anywhere. So pick something and go for mastery. Understand the basics of programming. Try to build backend systems from the understanding you've gained from how HTTP works, how the client server protocol works. Then think about data. How can I persist data? Here you will need to learn SQL. As a backend developer, engineer, SQL is non-negotiable. You should at the least be able to query a database, get relevant data from database, generate reports, understand how it works. And after this, you can build APIs that can fetch data, that can update data, that can create new data, mutate existing data. And finally, learn how to host some infrastructure. You build something, how do I make it accessible to other people? How can I share my brilliant, amazing solutions with others so they can learn and participate? That's everything from my presentation. Before we go into the practical bits, do we have any questions? I'll just give a minute and just confirming if we can still hear me fine.
No question.
Awesome. All right. If there are no questions, I would reshare my screen and jump into the practical bit. I like this to be as interactive as possible. I'd like us to participate. Um, I've prepared a ready-made bootcamp code that will be shared with you after now, but I've intentionally made this a from scratch experience, so you guys can see that there is no magic involved in this. But first, I'd like to gauge the audience so I understand how quickly we're going through this, or how much I would need to explain the things I'm doing. Um, how many of us have experience? You've written a line of code in any language at all? Just let me know. Or you've never written a line of code in any language. I think that's the better question. You've never written a line of code in any language. Is there anyone like that? Oh, we have someone like that. Okay. All right. Um, the other question is, I've written some Python. If you've written some at some point, you've had to write some Python. Let me see your hands. At any point in time, you've written just some basic Python. Okay, we have somebody. All right. All right. So we'll stick with the basics. I'll share my screen and we will be jumping into this. All right. Let's confirm if we can see my screen. Beautiful. So to make this very approachable for us, I am going to be writing this from the scratch. Let's talk about the objectives again. We want to build something that can, a bot. We want to build a bot basically that we can send messages to on Telegram and would get us answers. So we have about an hour to stretch ourselves and do as much as possible. All of us, including myself, let's assume we don't know this and we are learning together, and we would be helping each other basically build this out. Now, this is the backend bootcamp repo I have set. I'm not going to get into this. Hopefully, as part of building this project, would have touched upon many of the important pieces in this project, right? And then when you get to see them, it's much more approachable for you. And hopefully you have a fun time exploring that. But now I'm just going to create a new file. By the way, I'm inside of VS Code. VS Code is basically a code editor. And right now, this is no different from, say, I'm on Notepad or Microsoft Word, but this is meant for writing code. And I'm going to create a new file. I'll call it bootcamp.py. And here's my new file. I'm just going to disable AI here so that we don't have distractions from that. And this is Python. Some of us have not written any line of code, so I'll just give us some primer. Python is a very simple programming language that reads almost like English language. And I can say print hello world. And if I run this, and I say Python bootcamp, and you see what it just does is it prints hello world to the console. It's as simple as that. If I say my name is Emmanuel, which it is, it basically does the same thing. My name is Emmanuel. It prints that out to them. So print is a command, is a function basically that does anything you ask it to do. And let's do something a little bit more complicated. Let's ask for an input, and let's change this from my name is Emmanuel to what is your name? What is your name? Right. And if I run this now, it prints what is your name, but the program ends immediately after it prints what is your name. So how about we ask the program to wait to collect the name so that it can actually know what the name is. And this is where a function called impute is very nice. So if I say impute, what is your name? And I run that, Now it says, what is your name? And it is waiting for me. And if I say Emmanuel, then the program ends, right? But nothing happens. How about we store the answer, what is your name, somewhere and use it to do something small? So let's say name equals to input. So I'm basically saying I'm creating a variable called name and assigning whatever we respond with into name. And then I can then print name is a nice name, right? So now let's run this again. And it says, what is your name? And I say John. And then you see right on that, it says John is a nice name. And if we run it again and say Emmanuel, which is actually my name, it says Emmanuel is a nice name. So this is no longer fixed to Emmanuel. This is now storing things in the variable. I just did this to prime us up on programming. This is literally how programming works. Trying to get some information from the computer and getting some output from the computer. Now we want to build.
Hello, I think you're muted, Emmanuel, if you're still speaking. You're muted. Hello, Emmanuel, I think you're muted.
Can we hear me now? I think my microphone stopped working. Oh, sorry, so sorry about that. I hope we didn't miss too much. Just sharing my screen again. Can we see my screen? Please confirm it lights up. Perfect. All right. Now let's continue with what we're doing. I was basically talking about web servers. So we want to build a web server, and if we were going to build a web server from scratch, it's literally going to take us, months to build a proper working web server. Now, the good people of the internet have built in some web servers that we can easily use in Python to get started very quickly. So let's look for, let's pretend we don't know which one we want to use, and just open Google, right, and ask. And I'm doing this intentionally because you would need to research a lot as the backend engineer, right? And say backend servers in Python. And if I Google that and look at the list of responses we get, you can see Django, Flask, FastAPI, Tornado. There is a whole lot of them that are available for us to use. Now, I've intended for us to use FastAPI, so let's go with FastAPI. And we can say, getting started with FastAPI, right? 4 steps. Now, it says the first thing we need to do, actually, we can copy this entire line of this block of code. This is basically a web API that does nothing. But let's copy this and see what it does. So we copy this and we come in here and paste this. Right. Now let's run this code and see if we can make something there. And we do Python. Actually, bootcamp.py. And that's running. Oh, we actually need to run that. Let's go back to the documentation. We need to copy some line of code to keep it running. Let us So there is a number of ways we can do this. I'm trying to get us comfortable with working with documentation. So what you typically do is, so this is an entry point that they're giving us that we can work with, for example. So let's try this. So you can say FastAPI dev, but this is if you've used the PyProject.tol. Now we don't want to do all of that. Let's keep over this and see if we can find other alternatives. Let's say just something that's very, very simple and does nothing else. And maybe we need to search for more. Let's go back to Google and say, I know what to do, but just for the purposes of this lecture, let's say run FastAPI in a single file. And let's see what it says. So they have a guide here, run a server manually. And let's see what it does. So there is a command called FastAPI run main.py. And we can try that. Let's see if it works. FastAPI run bootcamp.py. Now, it says the term FastAPI is not recognized, and that is totally fine. Do not let errors scare you. This is basically happening because we have not configured the FastAPI in our CLI. Let's see if we find something else that works for us. So another approach that you typically use to run a FastAPI app is UVCon. And let's try the UVCon command. So it says you need to install UVCon for this. Let's try that. I think I already have UVCon installed, but just so we understand how this works, I'll show us again. So pip, for the context of people who are already not aware, pip is a package manager. You see, it says requirement already satisfied. That's because I had already installed this before the class. Pip is a Python package manager. And that means when you want to use code that has already been written by other people, you can use pip to install that code and make you work faster. So that's all it does. It's if you go to pip, the website, you can see there are millions of packages on pip, and lots of the code you would typically need to write, you don't need to write them by yourself. You would basically just you would basically just import an existing package and then use it to run your code. And what how does it say after we've installed pip? It says you would normally need to pass an import string. So basically from main import app, and then we would run this command UVCon main app. We pass in an host, we pass in a port. And let's try this and see if this works for us. So now we are not using a main.py, it's more of bootcamp.py. So we change that. And let's see if that works. And voila, we have our first app server running. Now, why did I go through the whole hassle of trying different things that worked and that failed? When literally in the README, so I prepared some READMEs for you in the getting started, and it gives you the step-by-step of how to run the server. We could have just come, and copied this and run it from the start. Why didn't I do that? It's intentional because something that I've noticed that puts off people early into their programming journey is failures. Failures are the default in programming. So let's zero out right. If you're starting up, if you're trying to program something and it isn't working, that is expected, because things fail. It's after you've iterated and iterated, going through documentation on the internet, going through forums, Stack Overflow, asking ChatGPT, and doing a whole lot of things. That is when you succeed. So don't get discouraged by simple failures. Just keep driving and go as far as you can. All right. Now that we have our web server running, we have it running on localhost. It's on port 80. So if I come into our web browser now and I say localhost port 80 and I run this, oh, it responds with a message, hello world. And if you come here and look at what we said if anybody eats / return message hello world. And if you don't believe that, we can change it. We can say, I want to say, welcome to Backend Development. And of course, we need to run our app again. Because we've changed the code. So when you change the code, you need to make sure you run the app again. And there is a neat way to make sure that app runs all the time. You just add in -- reload to the command you used to run it, and it will automatically check when the code changes and try to run it for you. Now we have this running. Let's go back to the browser and see. If I refresh this now, and it says, welcome to Backend Development. I mean, this is very, very basic, but this is the beginning of backend systems. If you understand this, then you're already a backend engineer, whether you can do things that do a lot of magic or not. Now, we still have a long way to go. We want to build something that connects to Telegram. How are we going to do that? Before we go that far, let's understand how this works a bit more. So I've imported FastAPI. If you recall, earlier I said FastAPI is a very nice web server that other people have spent a lot of time building that we can use rather than writing our own from scratch. And I create this app is basically me saying create a FastAPI server. And then what I say is app.get / this / you're seeing here, I'm basically saying if someone is on the root of the page, return this to them. How about we do something else and we say app.get, and then this time we say /food. And then, of course, we can define our function again. Food. And then we say return food. And then let's make that a list. Rice, beans, right? Now, if I quit this project and run it again, just running the code again, and we go back to our web browser and we refresh, it still says welcome to Backend Development, just like before. But we added some food. Why isn't that happening? If you recollect, food is only accessible on /food. So if I go and change this to /food, lo and behold, rice, beans, and dodo. That is basically how routing works in backend systems. Routing is basically when you say, I want this particular resource to be available on this particular identifier. The identifier we have defined here is /food. And on /food, it returns a list of food for us to eat or to deal with. I hope this thing can we give me some thumbs up or some feedback? Everything we're doing so far, is it making sense before we go into more complicated bits and pieces of this? Feedback from everyone. How are we doing so far? Any questions? All right, looks like there are no questions. In that case, we'll just continue Oh, there's one person, one hand up. Yeah. And yeah. Go for it.
Okay, good evening, sir.
Good
Are you hear me?
evening. Yes,
Yep,
you're good.
yes. Please, I didn't know how you connect your VS Code to Python because my one is on JavaScript. So I don't know how you connect your Python, your VS Code to Python. I was even trying to get it, but I don't know. Maybe I missed something. I missed some parts. Thank
Okay,
you, sir.
that's fine. So if you have VS Code installed, right, the only thing, like I said earlier, VS Code is basically like Microsoft Word for code. You don't even need to connect VS Code to Python. Now, I have a Python extension installed. If you come to extensions here, you can install a number of extensions for Python. If you search Python, and this is the extension marketplace, you'd see that I have the Python debugger installed, I have Python itself, I have Pylance, I have a number of Python extensions installed. But so far, we've not had to use any of those, right? We've just been typing and using the terminal. So if you have Python installed in your computer, if you run Python, whatever, what's it called? Whatever file you put in the Python code, it's going to run. So it's as simple as that. So just like when we started, I was just doing Python bootcamp.py, and it would print out whatever code we've put in. So that's pretty much it. But then check out some popular extensions, install them. Like, for example, some of the extensions I have installed just help to color these things properly. Show me that, okay, food is colored purple. In this case, it is a function, while this one is colored blue because it is a text. So those are some nice things that extensions will do for you, and maybe some autocomplete. If, for example, I remove the colon here, you can see that there is a red marker that comes up. Now saying it's expecting, it says expecting a colon after the function definition. So that's what the extensions do basically. So just guide you through. But they're not a requirement to complete this. But I encourage you to install them. They'll help you get things done smoother and faster. Yeah. All right. Anyone else before we continue? All right, so let's continue. Remember what we said is we want to create a Telegram bot that does something, right? So for a moment, I'm just going to quit this, and let's think about what we want before we even think about how the bot will work. Let's think about what we want the bot to do. So let's say our bot has just 3 functions. You can greet it, and you can ask it a question, and you can tell it bye-bye. So let's try and think about the workflow. I'm just going to open up a notepad, just literally a notepad here. For us to type. So if the user says hello, we want to respond, hey, I'm Richbot. How are you doing? If the user says, I want any ideas, guys? I want no, let's say, what's today's date? What's today's date? We want to respond, or what's the time? What's the time? So we want to say the time is XXX. And then if the user says bye, we want to respond, it was nice chatting with you. And then if the user says anything else, we want to say I don't understand that. So this is a very dumb bot, but it is a starter, right? I don't understand. The bot you deal with in your project is much more interesting than that. It's much more interesting than this. So do check that out and spend time with it. I don't understand. I don't understand that. All right. So how can we convert this plan? So this is our business plan. This is the bot that we want to deploy to our business. Right. How about we start with writing a function? Right. So let's just write a function that says bot, or let's say respond to user, right? And this thing takes in a string. It takes in user message, right? So the user has to type in a message, and then the name of what the function does is to respond to the user. And now we think if the user message is hello, we can now say return, right? Hey, I'm Richbot. How are you doing? Let's put that in here. How about else? If the user message is what's the time? Right? We can return. We've already prepared a message. Now we want to really return the time, right? So that means we need to calculate the time, right? So the time is plus time, right? There's no such thing as time. So let's create a time variable. Time equals to 2 p.m. However, the problem now is that this thing we always say the time is 2 p.m. But we want to really, really return the correct time. So let's go back to Google and ask how to check time in Python. How to check current time in Python. And you can see down here, it says you can say now is date time dot now. So apparently in the Python package, there is a package called datetime. So we need to import this. Let's go and do that. So we want to import datetime from datetime, import datetime. All right, and then it says we can get the datetime dot now. Okay, let's do that. So we can say time date time equals datetime dot now, and we want it in a nice format, and that's literally what this does. HMS just formats it into seconds, right? So let's grab this as well and say and we can now say time is equal to datetime dot now in the format of hours, minutes, and seconds, right? And then we return the time is time. Now, if the user says by another condition, what if user message is by? We want to say it was nice chatting with you. And then we want to say if it's anything else. So yeah, we will just use else. Return. I don't understand that. All right. Now that we have this thing, before we even go ahead to try and connect it to Telegram, let's test it, right, with our normal console and see if it's working. So let's do So what we need is we want to type it in the terminal, right? We want to type our messages, we want to pretend the terminal is Telegram. So we can say print welcome, type a message to continue. And then I would say while true. Now I'm saying while true because I want this to happen continuously. Input user message rather. Message is equal to input. And then of course we need to respond to the user, right? So we get response equals to, we call our respond to user function that we've defined. And then we pass in whatever the user has asked, okay? And then of course we print back the response to the user. Okay, so let's try this and see if it works. So we do Python bootcamp again. And it says, welcome, type a message to continue. So let's say hello. Oh, it did not work. It said hello back. You see, we have a bug. If you come back here and look at it, what we are printing is not the response, but the original message. So let's change that and fix our bug. Let's try this again. So we say hello now, and it says, hey, I'm Rich Bob. How are you doing? Let's say, what's the time? And it responds, the time is 9:23:45 seconds. Wow. Let's say, bye. It says, it was nice chatting with you. And let's say something else. Let's say, I'm back. And it says, I don't understand that. This is not part of the things I've been programmed to answer. And what we can even do to make this nicer is, just to add some flair to this. Let's add, let's say, whenever we type in something, it should be user. And whenever we are printing the response, it should start with bot, right? So something like this. And if we try this again now, hello, hey, I'm Rich, how are you doing? Bye. It was nice chatting with you. Hello, hey, I'm Rich, how are you doing? And this is much more nicer and much more interactive. All right. Now, looks like we have a working function. So I'm going to comment this out. And what commenting means is basically disabling some lines of code, because while this is nice, it's working in the terminal, our goal here is not the terminal. Our goal is to create a Telegram chatbot, right? That we can chat with on Telegram that works. So let's open Telegram for starters, right? This is my computer, and I hopefully have Telegram installed. This is Telegram. That is launching. So we have Telegram up here, but we don't really know what to do. So let's minimize this. I mean, we know what to do, but let's pretend we don't know what to do. And go to Google and say, how can I set up a Telegram bot? Again, I'm doing this, I know exactly what to do, right? But I'm doing this to emphasize that as a backend engineer, ask questions. There's a solution somewhere for you out there. You don't need to figure it out all on yourself. Just ask the internet. So look at this guide here. There is a whole YouTube video for it, but I won't be doing that because I've created Telegram bots multiple times, and I know the process. But basically, there's something on Telegram called bot father, and then you just tell it, I want the bot to ask you what do you want to name it. You give it the answer, and then it gives you a token. That's a security token that only whoever has access to can connect to the bot, listen for messages, and send responses. So let's do that. Let's go and find bot father. I think I chatted with bot father not too long ago. So this is bot father. If you don't have, anybody can do this as well. You can just search bot father on your Telegram. It's literally there on the app for anybody at all. So once you find bot father, you open bot father, and we can close this one. We don't need it anymore. Now within bot father, you basically say /new bot, right? /new bot. And then it's asking, how are we going to call it? Please choose a name for your bot. Let's call it Rich Academy. And it wants a username. I think we can go with the same thing. Rich Academy bot. And you see now, we have successfully created a Telegram bot. It has given us this token. I'll copy this. Now, if you go to t.me/Rich Academy bot, we have our bot. It's here. Our bot already exists, but it doesn't do anything. So let's say hello. It doesn't respond because it's useless. It's just an empty bot we've created. Let's say hi. What's up? We have a dumb bot on our ends. So how do we connect this bot to the code and logic that we've built? We have a business logic where we're a world-class backend engineering team, and we've built this very powerful business logic that can respond to certain messages, right? But we need anybody in the whole world to be able to connect to it. Let's save our token here. Just say Telegram bot token. And that's the one bot father gave us. So I've pasted this in here, and let's go back to that instruction. We were on Google just now, and it was literally teaching us how can I set up a Telegram bot. And then it says there is a Python library called Python Telegram bot. Oh, so there is a library. We don't need to go and implement the API by ourselves. So that's nice. Let us Google Python Telegram bot. And look at it, Python Telegram bot. Let's click on the documentation and see. So it says it's very easy. Okay. You just have to do from Telegram, import, update, and import this. Okay, so if we want to set up, we need to do pip install. You remember pip? I told you about this earlier. So let's do this. Copy this. Simple as that. And let's go back to our terminal. Let's install what it asked us to install. Python Telegram bot. You see, it says already satisfied, and that's because I did install this a while back. So that's successfully installed. What next? What do we need next? Unable to view my screen. Is that the same for everyone? It looks like it's just you. Do you want to rejoin the call? My screen is still up for the others. All right. So if we come back to the documentation, it says we need to import these two things. All right. So let's import these two things. Copy that and add it to our imports. Okay.
Yes, then.
Yeah, go on. Go for it. I thought someone was going to ask a question. No. All right. So we continue just where we stopped. And then it's asked us to copy this huge code, which I would explain. I'll explain all this in a second. So we come all the way down here and we paste this in. And it says this is a function. So this function basically is accepting, this function is accepting whatever message that comes in from Telegram. So what we are basically in the backend, what this is called is a callback. So what we are providing to Telegram here is a callback. Anytime a message comes into our bot, let this function be the one to process it. So let's call this Telegram responder. That's probably a name that makes more sense. And this update basically is, this object represents an incoming update. That's an incoming message from Telegram, right? Do not worry about the context. It's just referring, that there can be different types of messages. It can be media, it can be audio. Right now, we're just going to focus on processing text. So we will not bother about this. And right now, what they just respond with is, hello, the user first name. And we don't want that. We want to instead use our logic that we have defined in respond to user. So how about we get the user message, just like we did when we were building our terminal programming. We say user message. So we need to get that from the update equals update dot. So if we scroll through what's available, effective message, and then we look for, it's just text. You can see there's audio, there's a whole lot of things in here. And then there is text. So we just want the text. So that is the user message. And then our response, just like we did before, our response will be equal to respond to user, our function that has all our business logic, and send the user message to it. Now, we want to respond to the text message with our response. So we just send reply text. And that would be, what text are we responding with? Our response. All right. And then once we've configured this callback, so this is our Telegram responder, right? We've created this. Now let us connect this Telegram responder to Telegram. Now, do we do this? We need, remember that bot father gave us a token that we stored, a Telegram bot token. So this is building our Telegram app. Let's change this so that this doesn't conflict with this. I will rename this to Telegram underscore app equals to application builder.token. So we need to put in our token here, and we've already assigned our token to a variable Telegram bot token dot build. Now we need to add the handler, that's Telegram responder, to undo messages for us. So we say Telegram app dot add handler command handler. So this command handler basically only responds to hello, but we want to be able to respond to anything at all. So let's see, how can we make the command handler respond to anything? Looks like the command handler would not work for this purpose, because we want it to respond to free-form text, right? Not just hello. We want to be able to do that in a single handler. So let's go back to the documentation. We need something else that better suits our purpose. So documentation. And that's literally how you solve problems when you're building backend systems. Documentation is your best friend. So you would typically find examples in documentation, and let's look for a good example. Conversation bot.py. This seems Let me stop notifications from distracting us. So, let's open this up and see what it does. So in here, they want to be able to respond to anything, right? So let's look at what they do when they configure the application. They import things just like we do. They have this start the conversation and ask the user about the gender and a number of things. And then in the main app, this is the build it. And so instead, they use a conversation handler. Perhaps this is what we need. So let's try using a conversation handler. Before we do that, let's just look at other examples, see if there's anything simpler we could use. This is EchoBot, and this just responds to, this still depends on commands. So on a non-command message, so this is what we need. We need an handler that can handle non-command messages. So there is something like that. So this is what we need. So let's copy this. And so you see how we figured this out. With AI, this process would even be much faster. I could literally go to ChatGPT and say, what line of code do I need for a message that is not a command? I need to give that back. But I'm trying to go through the first principles just so we have a good understanding of how to debug, how to figure things out now. All right, so let's try this. And you can see that many things have been underlined here. Let's try to fix that. First of all, it was called application, but here we call it Telegram app. So let's change that. Then message handler is not imported. So let's go to the top. We are no longer using command handler, so we can remove that. And we want to use message handler now. So let's bring it in. And now that has disappeared. Now filters. We need to import filters as well. But I don't know where they imported that from. So let's go back to the documentation. Where was filters imported from? If you go to the top, you see it was from the same telegram.txt filters. All right. So let's try that. Let's see if it will work. Filters. It came up. Oh, now it's gone. Now echo. Of course, we're not building echo. What we are using is our own Telegram responder. So let's put that in. Telegram responder. And then finally, Telegram app run polling. So run polling, I would explain this to you. Polling is basically process in backend where a client initiates a request and waits until there is a response. Once the request timeouts, it initiates another request again. So what this basically does for us is behind the scenes, it calls Telegram. As any message comes to our bot, if a message has come, it responds immediately and then sends another request. So it will continue to send requests to check until the end of time or until we stop it. That is literally what polling means. So it's very simple. Now we have, this very simple code is, this is everything is probably about from here down, just about 20 lines of code. Let's run this and see if it works. It's not guaranteed to work, but we are equipped with our brains and with the internet, so we can figure it out if it doesn't work. And I think it's working already, but I'm just going to cancel this just so I can give some feedback. So just before polling starts, let's say print Telegram bot is now connected to our backend. All right. And let's see if that actually happens. That's how we know if our code is running or not. So we run the bootcamp file again. And you see the message, Telegram bot is now connected to our backend. Okay, is this a lie or is this true? Well, it's the moment of truth. Remember in the past, when we sent hello, hi, what's up, our bot never responded. Will it respond this time? That is my prayer, but we can never tell. So let's say hello and see what happens. Hello. Oh, so smart. And you see, this is Telegram responding, hey, I'm Richbot. How are you doing? And let's say, what's the time? And it responds instantly. The time is 9:42:25 seconds. And then we say, are you sure? And you remember, are you sure it's not in our specification? So he says, I don't understand that. And then if we say bye, it was nice chatting with you. Aren't we amazing? We just built a bot in roughly 40 minutes in 20 lines of code. And that's really what backend systems are all about. You just have to go at the problem till it works. We could take this a step further and connect it to an AI agent, right? Say OpenAI, Claude, that actually understands things. Yeah, I have some bots set up myself. I want to show you that I used to do some work personally. But yeah, it's fun, it's empowering. I got into software engineering myself because I found it very empowering. And I usually like to preach that to people who are interested in becoming engineers as well. Beyond the upsides in terms of large salaries, reputation and all of that, you are empowered to solve problems that are within your reach. Every one of us has to interact with a digital device. Being an engineer empowers you to be able to solve problems, create unique solutions that can handle specific problems of yours. For example, you can take the small code we've written and make some small changes and build maybe a Telegram or a WhatsApp bot that sends good morning to your girlfriend every day. If that's a problem in life, and you usually forget to say good morning to your girlfriend. You understand what I mean? And that's really the idea of programming, empowering yourself and building solutions with software. That's everything I've prepared for you. Like I said earlier, this bootcamp file here, I've sent the GitHub to Victoria already. She'll be sharing with you. Contains a lot of things, including a much more sophisticated Telegram bot. Takes you through the module 1, takes you through HTTP fundamentals. Module 2 gives you some introduction into FastAPI. Module 3 talks about routing. I gave you a bit of basic of routing. That was when I, set up food endpoint that returned only food, and then the home endpoint that returned welcome. And then data persistence, we couldn't get to this, but this will teach you about databases, interacting with them, a little bit of SQL, auth security. This is securing your APIs. You see, when we messaged BotFada to create a chatbot for us, it created a token. Now, if you want to create an API other people can connect to, you too need to be able to create a token that you share to them and say, keep this token a secret. Anytime you want to send a message to me, send it alongside so that I will know it is you. That is the only time I will answer you, right? That is what authentication is all about. Then external APIs, this is about integrations. We just integrated with Telegram. Telegram is an external API. We didn't have to do any of the manual API wiring because we used the library. Many times you wouldn't have to do the tinkering yourself, but many times you would. So this is what this module is about, connecting with external APIs. You want to feed in from Google APIs to be able to do search. Maybe you want to integrate search into your Telegram bot, right? So that you don't need to do google.com to search for things and just say, what is this? And then it just goes and searches and responds to the answer. If we wanted to do that on this call in another 15 minutes, we could do it. It's, it's that straightforward, really. And that's really what working with external APIs. There's so many powerful APIs. WhatsApp has an API, Instagram has an API, Twitter, Facebook, they all have APIs. Every service has an API that you can connect to and make things happen. You can connect to an API that sends emails for you, checks the weather, checks the sports, whatever you're interested in. Then testing. This is a really important part of building backend systems. You have some business logic. Does it work? How do you validate that this works? How do you validate that when you've made changes to your code, the things that were working before do not stop working? That is what Module 7 is all about. And Module 8 is your final project, which is a Telegram bot. You can read all about it here and set it up. Victoria will share this with you, and feel free to reach out to me on, my email should be on my GitHub. So feel free to ping me from GitHub. If you can also reach out to Victoria. Victoria, feel free to share my email with anyone. You can follow me on X as well or on LinkedIn, and ping me with any questions you have. I may not be able to get to you in time, but I would eventually get to you. Yeah. But then I'm encouraging us all to crack on, to get our hands dirty. You learn by doing. You'll never learn by watching a million videos or reading a million books. You learn by getting your hands dirty and building things. And before you know it, you're shipping things and you're working in Google, or you're running your own business and you're building powerful systems with software. That's it for my class for today. Thanks, everyone. I hope you learned something. I hope you had a good time.
All right. Thank you so much, Adevi, for this powerful session. Thank you so much. Thanks, everyone. Yes, for joining in. It doesn't end here. Like I said, the materials, I'll share that. I remember there's lots of assignments from day one, from the front end, the back end, the product design that you have to complete, and for you to get your certificates. And also there will be monetary prizes for the best project or the best work. Yeah, so ensure you do your assignments and ensure you also follow us on our social media. So the link to the social media platform will be posted again, and please ensure you fill the feedback form as well. So thank you so much, everyone, for your time, and please have a good night rest. Thank you. Thanks, Adelia.
Hold on. 1 minute, please. 1 minute, please. 1 minute, please. Sorry. Victoria, do you want to introduce Akachukwu, or do you want me to? Hello, Victoria.
Sorry, I didn't get that.
Yeah, do you want to introduce Akachukwu for to introduce the boot camp, or do you want me to introduce him?
Yeah, you can go ahead, please.
Okay, thanks everyone. So thank you very much, Emmanuel. We really appreciate this session, and the insights and the hacks you gave us on managing our relationships with chatbots. Very valid advice. So we'll be putting tech to good use. Thank you very much, and thanks for all the knowledge shared. I want us to first things first, please help us improve. Fill the feedback form. No matter what the feedback is, good or bad, we are happy to have them. Be as honest as possible. Don't hold back. That way we are able to improve. The goal is to, continue to improve and, continue to be the community and support everyone in, our tech journeys. So before we close, I will introduce Akachukwu. He is the program manager for our bootcamp. He will be sharing, he'll be giving us 1 or 2 information about what our bootcamp is all about. And I think it's something that, we benefit everyone in the community. So I would introduce Akachukwu. Hey, hi Akachukwu, if you're on the call, kindly, talk to.
All right, good evening. Can you hear me clearly?
Yes, I can hear you.
All right, amazing. It's great to be here. thanks to the facilitators that have handled the different classes for the past 3 days. So this is like a tip of the iceberg on what Reach is about and what we want to attain. And so, not to take too much of your time, our bootcamp, right, is one that is here to solve a really, really key problem in the industry of tech, and even those that want to transition into tech. It's easy to go online and learn and watch videos and just do 1 or 2 things and believe that you are ready. By the end of the day, you're not job ready because you don't have you don't have practical knowledge of different projects. And a lot more times, with where the world has gotten to, the industry is right now, it's important to do things in teams. A lot of times I've interviewed several candidates. You get to ask them questions like, have you worked in a team? How many teams have you worked in? What was the total number of people in that team? So we've seen that it's very important to, especially when you want to get jobs now, to have worked in teams, because collaboration is key. And then also just being able to handle human behavior. All right, so our bootcamp is quite simple. It's where we give you an opportunity to be a part of teams and gives you projects, right, running for upward of 3 months, right? We'll have front-end, back-end, product designers, QA, and product managers. Those are the roles that will be available in each team. So people will need to fill in those spaces, and then we'll give you a project so that by the end of the training, you would have had about 2 to 3 projects that you say, okay, I was a part of a team, and we came and we solved these problems. And we're going to be giving you real life problems that you will find solutions to. Okay, I believe that as details are being shared, you will be given more information on how to be a part of this if you are really interested, and also to reach out to people around you that will be interested in this as well. But that's what our bootcamp is about, to get you job ready with practical knowledge. Thank you so much.
Yeah, thank you, Akachuku, for giving that insight. Yeah, so in the end, the goal is to, stay in the community. This is just the beginning. There's a lot installed, and as things unfold, you get more information. Yeah, you could, the platform is there, so use the platform. If we have resources, we'll also show on the platform, so you would get communication as time goes on. So thank you. I would hand over to Victoria for if there's any more thing. Otherwise, I think I would say good night and have a good night rest. Victoria?
All right. Thank you so much. Thank you, Toby. Thank you, Coach Patrick. Thanks, everyone. Please enjoy your evening. Good night, everyone.